In this video, I will show how to find the area of the region between the graphs of two functions. In this case, we have two quadratic functions on the interval from 0 to 3. So the first thing we want to do is we want to find whether these functions intersect or not on the interval from 0 to 3. And if they do, we would like to know which function is above which function and on which interval. So to find the points of intersection, we set the functions equal to each other and bringing all the terms to one side and setting it equal to 0, we get the following. Then dividing it by 2, we can actually factor this 1. So the points of intersection are 2 and -1. So these two parabolas intersect at 2 and -1. However, only one of these points is in the interval from 0 to 3. So the picture that we're working with is the following. We have upside down parabola and we have upright parabola, and they intersect at -1 and 2. We're looking at the area between these two functions on the interval from 0 to 3. So that means we're looking for this area. So from 0 to 2. And for this area from 2 to 3. So if we label our functions like this, so the first quadratic function, if we call it f of x, then this is my f of x. And if we call this function g of x, then this is g of x. So what we notice is that on the interval from 0 to 2, g is above f. On the interval from 2 to 3, f is above g. So that means to find the area, we're going to set up the following integral. We're going to write it as two integrals. One from 0 to 2, and there we're going to subtract f from g. And then we're going to set up an integral from 2 to 3, and on this interval we're going to subtract g from f. So let's go ahead and set this up. So first integral from 0 to 2, and we have 5 minus x squared minus x squared minus 2x plus 1 in parentheses dx plus integral from 2 to 3 x squared minus 2x plus 1 minus 5 minus x squared in parentheses. The reason we have to do it in two integrals because the formula for the area between the graphs only works when one function is above the other one. Simplifying the integrands, we get the following. 4 minus 2x squared plus 2x dx plus integral from 2 to 3 2x squared minus 2x minus 4 dx. And these are simple polynomials, so it's very easy to find their antiderivatives. So we have 4x minus 2/3 x cubed plus x squared from 0 to 2, and plus 2/3 x cubed minus x squared minus 4x from 2 to 3. And we're going to carefully evaluate these functions at the limits of integration. So 4 times 2 minus 2/3 times 2 cubed plus 2 squared minus 4 times 0 minus 2/3 0 cubed plus 0 squared plus 2/3 3 cubed minus 3 squared minus 4 times 3 minus 2/3 2 cubed minus 2 squared minus 4 times 2. And carefully, we're going to perform all the arithmetic. Here we have 8 minus 16/3 plus 4. Here we have 0. Here we have 27 over 3, 9 times 2 is 18, minus 9 minus 12, minus, and here we have 16/3 minus 4 minus 8. So if we distribute everything, we have 12 minus 16/3 plus, so this can be computed, so it's just plus -3, which is -3, and here we have 16/3 minus 12, which can be written as -16/3 plus 12. So we have 24/21 minus 32/3. So finding the common denominator 3, it is 63 minus 32/3. So the answer is 31/3, or 10 1/3. So this is the total area between the two given functions, or between the graphs of two given functions on the interval from 0 to 3.